Okay. Now we go over to design with classes.
Is it because you didn't click on the PowerPoint itself? Because
Sorry, say again.
try tapping on the PowerPoint once, and then maybe it'll work.
Okay, thanks. Okay, so far I mentioned about procedural programming, right? Procedural programming is you writing the program to make a function. So we define the function, and each function you have some function you have no parameter, but some function you have more than one parameter, right? And whenever you call the function, you have to passing argument into the parameter, right? That is what you did with last week. We learned everything about the function. So procedural programming is writing program and made a function that performs specific tasks. And procedure is typically operate on the data items that's separate from procedure. Right? That is the one whenever you call the function, you have to passing the value into the parameter of the function. That's why they normally separate from the procedure, right? And if you come back to our example, you can see for this one. If you come back to the example, you can see for this that's one here, right? So for this one here, you have one parameter is a number, right? Now I think it should be better to work with the other one. This one here. You have the one parameter, it's the price here. Right? So we see in your main program here, in your main program, whenever you call the function, you passing value into the parameter of the function. So basically this one is not included in your function. Right? And whenever you call the function, you have to passing it argument into the parameter. Okay, and data item commonly pass from the one processor to another. And this one focus on to create the procedure that operate on the program data. But this one has a problem here. Whenever you change the function, right? Whenever you change the function format, so the way you passing the value, it has a huge problem. It has a huge problem because you see, whenever you have to take the data out of the function, you passing it into the function. So whenever you change the function format, or you change the data format, you have a huge problem with this one. That's why they come with another step, another approach. It is object-oriented program. It is focused on the creating the object. So what is object? Object is entity that contain the data and procedure. Data is known as the data attribute, and procedure are the known as the method. So you can think about this one. The method, you can think about the function. You can think about the function. And the data, you can think about the parameter you have for the function here, right? You can think about that way. So, but the thing is that here you encapsulate everything into the one object. So everything it's only encapsulated into the object. So whenever you change it, it not impact to the function you call because it's already encapsulated into the object already, right? So that is the process of the encapsulation. You combining data and the code into the single object. You see, you have the both of the method and you have the both of the attribute. You encapsulate it into the one the class into one entity here. I think I don't know if I showed this video to you before, but I think it's very yeah.
A popular interview question concerns the 4 core concepts in object-oriented programming. These concepts are encapsulation, abstraction, inheritance, and polymorphism. Let's look at each of these concepts. Before object-oriented programming, we had procedural programming that divided a program into a set of functions. So we have data stored in a bunch of variables and functions that operate on the data. This style of programming is very simple and straightforward. Often it's what you will learn as part of your first programming subject at a university. But as your programs grow, you will end up with a bunch of functions that are all over the place. You might find yourself copying and pasting lines of code over and over. You make a change to one function and then several other functions break. That's what we call spaghetti code. There is so much interdependency between all these functions, it becomes problematic. Object-oriented programming came to solve this problem. In object-oriented programming, we combine a group of related variables and functions into a unit. We call that unit an object. We refer to these variables as properties and the functions as methods. Here's an example. Think of a car. A car is an object with properties such as make, model, and color, and methods like start, stop, and move. Now you might say, but Mosh, we don't have cars in our programs. Give me a real programming example. Okay, think of the local storage object in your browsers. Every browser has a local storage object that allows you to store data locally. This local storage object has a property like length, which returns the number of objects in the storage, and methods like setItem and removeItem. So in object-oriented programming, we group related variables and functions that operate on them into objects. And this is what we call encapsulation. Let me show you an example of this in action. So here we have three variables: base salary, overtime, and rate. Below these, we have a function to calculate the wage for an employee. We refer to this kind of implementation as procedural. So we have variables on one side and functions on the other side. They are decoupled.
Okay, so we see the variable is outside, right? Outside the function here.
Now let's take a look at the object-oriented way to solve this problem. We can have an employee object with three properties: base salary, overtime, and rate, and a method called getWage. Now why is this better? Well, first of all, look at the getWage function. This function has no parameters. In contrast, in a procedural example, our getWage function has three parameters. The reason in this implementation we don't have any parameters is because all these parameters are actually modeled as properties of this object. All these properties and the getWage function, they're highly related, so they're part of one unit. So one of the symptoms of procedural code is functions with so many parameters. When you write code in an object-oriented way, your functions end up having fewer and fewer parameters. As Uncle Bob says, the best functions are those with no parameters. The fewer the number of parameters, the easier it is to use and maintain that function. So that's encapsulation. Now let's look at abstraction. Think of a DVD player as an object. This DVD player has a complex logic board on the inside and a few buttons on the outside that you interact with. You simply press the play button and you don't care what happens on the inside. All that complexity is hidden from you. This is abstraction in practice. We can use the same technique in our objects. So we can hide some of the properties and methods from the outside, and this gives us a couple of benefits. First is that we'll make the interface of those objects simpler. Using and understanding an object with a few properties and methods is easier than an object with several properties and methods. The second benefit is that it helps us reduce the impact of change. Let's imagine that tomorrow we change these inner or private methods. None of these changes will leak to the outside because we don't have any code that touches these methods outside of their containing object. We may delete a method or change its parameters, but none of these changes will impact the rest of the application's code. So, with abstraction, we reduce the impact of change. Now, the third core concept in object-oriented programming: inheritance. Inheritance is a mechanism that allows you to eliminate redundant code. Here's an example. Think of HTML elements like text boxes, drop-down lists, checkboxes, and so on. All these elements have a few things in common. They should have properties like hidden and inner HTML and methods like click and focus. Instead of redefining all these properties and methods for every type of HTML element, we can define them once in a generic object, call it HTML element, and have other objects inherit these properties and methods. So inheritance helps us eliminate redundant code. And finally, polymorphism. Poly means many, morph means form. So polymorphism means many forms. In object-oriented programming, Polymorphism is a technique that allows you to get rid of long if and else or switch and case statements. So back to our HTML elements example, all these objects should have the ability to be rendered on a page. But the way each element is rendered is different from the others. If we want to render multiple HTML elements in a procedural way, our code would probably look like this. But with object orientation, we can implement a render method in each of these objects, and the render method will behave differently depending on the type of the object we are referencing. So we can get rid of this nasty switch and case and use one line of code like this. You will see that later in the course. So here are the benefits of object-oriented programming. Using encapsulation, we group related variables and functions together, and this way we can reduce complexity. Now we can reuse these objects in different parts of a program or in different programs. With abstraction, we hide the details and the complexity and show only the essentials. This technique reduces complexity and also isolates the impact of changes in the code. With inheritance, we can eliminate redundant code, and with polymorphism, we can refactor ugly switch case statements.
Okay, so basically.
Hello, it's me, Mosh again. I wanted to say thank you very much for watching this tutorial to the end. I hope you learned a lot. Please share and like this video to support me. If you want to learn more about the object-oriented,
Explain about the four pillars of the object-oriented. You have encapsulation, you have abstraction, you have inheritance, and you have polymorphism. We explain everything in this class later by today, one by one. Okay, now we mentioned about the object-oriented. The data hiding is the abstraction here. It mentioned that's one. The data hiding its object data attribute are hidden from the code outside the object. So you see, when we're hidden from the code outside, that you are the one who control it. If you want to some of the method or some of the attribute expose to the public, you can do it. Or if you want to hide it, it's totally your control here, right? So I set it restricted to the object method, and it can protect from the accidental corruption or outside codes. You do not need to know the internal structure of the object. It makes it simple, right? So whenever you call it, you just need to know what dice do only. You do not have to understand internal code of the method here. Also, you can use the object reusable, right? It's the same object can be used in the different program. It is a way when you work the inheritance. It's inheritance here. So you think about, you have the example, you can have the 3D image object that can be used for architecture and the game program. So you can use the one 3D image object, but from that you can generate for many instances from that. Okay, so you have some of the example of the object. The first thing you have the data attribute. It is everything about. You can think about it's a variable, right? You can think about it's variable, or you can think about parameter. Whenever you go with the function here, it defines the state of object. For example, if you have a clock object, you only have the second, you have the minutes, and you have hour data attribute. You can think about, right? So whenever you see what time is it, you need to sum up the attribute with the second, minutes, and hour here. Also, you can have the public method. It allows the external code to manipulate the object that is exposed to the internal. You can access it and you can manipulate it, change it, or delete it, whatever it is. And the second, it can have a private method. Private method is used for the object in working. So think about this one, right? Whenever we want to look what time is it, you know that you have the minutes, second, and the hour. That's all you care. But actually, in order to show a second, minute, and hour, you have to method to increase every second, to increase every minute, and increase every hour here, right? But from the user point of view, you do not have to care about that. That is a hiding data, right? Makes sense. Okay, now also we have definition about the classes. Class, it is a code that specifies the data attribute and the method. So remember, you have object. Whenever you have object, you have, whenever you have object, you have the attribute and the method here. And remember about the method, you can think about it is a function, right? You have the function. And attribute, you can think about it's a variable going with the function. Right? So the class is a clause that specifies the data attribute and the method of the particular type of object. It's similar to the blueprint of the whole or the cookie cutter when mentioned it. Now you have instant. It is instant. It is the object created from the class. So you are the one who defines the class. We are the one who code and who define the class, right? So when we have the class, you can use this class to generate the instant. The same when we use the function, right? So when you define the function, you can use the function whenever you want here. So instant is the object created from a class similar to specific how build according to the blueprint. And there can be many instances from the one class. That is make it simple, right? You can think about when you define a code, when you define the class, you can use that code to generate from multiple instances. You think about this one here. It's very straightforward. It's very straightforward when you want to understand about the class and instance here. You can think about the cookie cutter here. Right? The cookie cutter, you can think about it a class, and you are the one who makes the cookie cutter. Right? That is class. You can think about you are the coder, and who makes the cookie cutter. But when you have the cookie cutter here, you can use this cookie cutter to generate for multiple cookies. And you see cookie here, you can understand that it is instant. Right? Okay, make sense? Okay. So the same this one, when you have the blueprints of the house, and you can use the blueprint here to build one house, two house, and the third house, and so on here. Okay. Now, okay, so you understand about the class and you understand about the instance. Now, the class is the one you have to define. You are the one who have to code what class it is. Class definition is a set of statements that define class method and class data. Okay, and the format here, it begins with the class and the class name. And remember, this one is a class, it is a syntax here, and the class name, whatever it is, you can define whatever the name it is, right? And normally class name often start with the uppercase letter. Now, remember that class, you have attribute and you have the method, right? You have the method also, right? So when the first step you define the class, the second step you have to define the method here. The method is that definition like any other Python function selection. But remember that the method is the same with the function you did so far. But one thing about this one here, for every method, for every class here, you have the same parameter. Same parameter is required in every method in the class reference to the specific object that the method working on. That is something you have to pay attention. If for every instance, you have the same parameter. Same parameter is the one who tell you which instance you are working with here, right? Okay, now you also have the initializer method. Initializer method, it's automatically execute when an instance of the class is created. So whenever you generate an instance, it always executes the initializer method, whatever it is. It's over whatever it is here. And it should initialize object data attribute and assign the set parameter to object that was just created here. So that's why in every class, when you define the class, you always have the step to define the initial function method here. Right? And the method here you might have the one parameter or two parameter or three parameter. It's up to you. For this one, you have no parameter here. Self here, that means it linked to the instance you are working. Okay. And usually it is the first method in the class definition here. Now, it's too much about definition. Now think about this one here. I think about this one here, right? For this step, I want to create a class with the name is the core here. So here's the syntax, right? So here's the syntax here. Is the syntax. You see, I use the syntax class, and this is the name of the class. It's the name of the class here. And remember that for every class, you always have the initialize method here. Initialize method. Right? For this one, you do not have any parameter. remember that you only have the self that is tell you that you are working with the instance here. But for this one, you can understand that you have no parameter in this function. And this is the method, but you can think about the function. Right? Sometimes I mention method, but sometimes I mention function, but actually they work quite the same here. And you have no parameter for this one here. So in the init method, initialize sign up data attribute to the head. You see, whenever you have the class of coin, and the first step, whenever I generate the instance, I assign the sign up to the head here. So whatever it is, when I generate the instance, it only beginning with the head, right? And now
that's like defining a default.
yes, you can think about the default, initialize the default. Yes, that's the correct definition here. That is the one method. That is a method. And remember that for every class you will have the init method here. And that's the process when you assign some of the default value to the attribute of the class here. Okay. The second one here, the second method here, I define the toss again. This have no parameter. It's only linked to the instance here. Right. So for this one here, whenever I have work with the random number. Whenever I have the number 0, I can define it's a head, and whenever I work with the number 1, I have defined the tail here. Right? Because when I toss the coin, I only have two possibilities, right? Head or tail, right? So that's why I work with the random. So I only have the two number 0 and 1. So it returns 0, it is head, and it returns number 1, it's a tail here. Okay, now I have the one method. I have the second method, and I have the third method. Third method actually is taking out the value after you tossing the coin, right? So it can be up or down. It can be up or down. Also it can be head or tail. Make sense? So it's very simple. It's very simple definition of the class here, right? So basically, after this one here, you can think about it. After this step, you will generate the class with the name of coin, right? With the name of coin. With the name of coin here. And remember, whenever you use the class here to generate instance, every other coin you generated from the class here at the beginning, they only have the state head, right?
Always default to head.
Yeah, the default head. And after that, you can toss it, and it can tell it the tail or head here. Okay, that is the way you define the class, right? It's a way to right here. Now you remember about the example I give you here. That is a step when you define the class, right? That actually you can think about this one here. That is a step you define the class. You make the cookie cooker, and from the cookie cooker you can generate many cookie here. That is an instant. That you use a class, and you can generate it into multiple instance here. Now, how to create a new instance from the class here? That's the example. That is the syntax here. Right? You can use my instance. That is the name. You can put whatever you need, and you see it is a class name here. Right? That is the way you generate an instance from the class here. And to call any class method, you know that for every class, when you define, you have some of the method, right? You have the sum of method. And if you want to call any of the class method, you can using the create instance and use the dot notation here. And see that is syntax here. My instance is the instance generated from the class name, and absorb in that one you can call the method you define in the class here. So you see you have initial, you have init method, right? And you have toss method, right? And you have the get side method also. Remember that the reference to the cell here is a pass automatic. Whenever you generate instance, it means the pass it automatic to the instance you are working with. Okay, so here is how you create a instance here, right? So remember that I already defined the coin class before, right? And now I want to create the instance from that one, or create the object is the same, right? So I see I assign my coin to the coin here. So when we have the assigned instance here, I can take it out. I can use any method of the class. So see, my coin here is the name of the instance I just create, right? And the get sign up here, it is the method of the class I define here. So what do you think? After this step, what is it? After this step, what is it? What do you think? What do you have after this step? If you come back to the class coin definition.
You either have heads or
Yeah,
tails.
you have the head. No.
No, you only have.
Yeah, that is initial, right? So remember here, one more thing here. Remember, whenever you create the instance, the init method will automatically execute. Remember that?
It's automatically
Yeah,
default to head.
Yeah, it automatically executes. That's why whenever you generate instance, at the beginning, you always have head here. That's why always have the head here. Make sense? Okay. Now, after that one here, if I want to toss the coin, I use the instance name and the method here. And again, for this one, the last one here. After the toss, you can take it out you can take out the state of the side of the coin. It can be head or tail. That's why you use the method here. Get side up here. Okay. Now, after this one here, see, you call the main function here. The main function actually you generate the instance, right? You print out the default value and you toss the coin and you print it out. It's a head or tail here. Make sense? Okay. Now I think with this one I can go back with it's module 9. Module 9. On my coin. Okay, that is a class here, right? So remember when I define this class here, when I define this class, when I define this class, I store it in the Python name coin module here. I store whenever you define the class, it store the same in my Python. That's why I store it in the module name is coin module here. Now, in my program, I have coin here. In my program here, we have this one now. This one I already do all of them into the one file. That's why I do not have the code import it here. So for this one here, right? The first step, I define the coin function here. Sorry, I define the coin class here. The coin class here. I define the coin class. I do everything. That is a init method. It only needs in every class, and it only have the default value is head here. Now after that, I can toss it and I can think you have two possibilities, it head or tail. And the last step here, it's the third method here. I can print it out. It is head or tail. And now in my program here, the main function here, I generate the instance. Remember, after in the generate instance, I print it out here. Get my coin get size. This one at the default at the beginning only head. And after I toss it, of course you can have the head or tail, whatever it is. And now we can go into function here. Now we can think about this one. I run it, right? So you can think about this one here. You see? Wait.
Run it again because it probably deleted something.
So why? What is this? What's my program? Yeah, right. So see, Z is a default. It's always head here, right? And after that, it can be tail or head. It's a V. Or you can verify by this one here. For range head here, right? And you can call the main function here. Do it on head to see what you have. Okay, so we see I do it 10 times here. Every time, I see. Every time, right? I have the head. Every time I have the head here.
Every time it defaults back to.
Yeah. Make sense? Okay.
All right. Yeah. You gotta define the default for the
Mhm.
class. Once you have that, you can then go from there.
Okay. Okay, so now that you know how to define the class, right? And how to define the method in the class, and how to generate instance from the class, and how to call the method from the instance of the class here. What else? Okay, so you can see how we explain this one. What is it? This. How can I move this one up? Okay, so here's the thing, right? So whenever you generate instance from the class, it always, the first step, it always calls the init method here, right? And that's why at the beginning, every time you generate instance, it had here, every time. You see, the first step here, the object is created in memory from the core class, right? And the second step here, whenever you generate instance, the first step is always execute init method, right? That's why whenever you generate it, the first step here, you always have head here, right? It always has the head here. What is it? What? Okay, you always have head here. And after that, after you have the head, now if you toss it, you have two possibilities: it head or tail, whatever it is. And you got the third method here. You get the side here. It's a print down. It's the head or tail only. Right? Okay. Now. Okay, so that is program. That is example. I store them into one program. I store it into one part. Right? But now you can, in some cases, you can create a class and you can store it in the separate file. You can store it in separate file, right? And in your program, you can import that file, and you can correct it out the instance from that file here, right? So the class can store in the module, right? So see, the file name for the module must be and is the P1, the same with the Python program, right? That's I store it in the core module here, right? And the module can be imported from programs that work with the class. So I have another program here, core store. For that one, I import the core module in a module into my program here. Okay, now you can see for this one here. You can see for this one, I have the core module and core post here. Where am my program? Yes, core module here, right? So see, in this one, I only define the class name only. I have no program for this one. I only define for the class. I store it in the core module here. And where my core post, yeah, this is program here. So see, when I work with the program, the first step, I have to import the module name. And the name of the module, I store it here in the core module. That's why I have to import the core module for here, right? And of course, after that, you can generate the instance here. But remember that whenever you generate instance, you have to use a combination of the module name and the class here. Huh? Okay, the module name, it is the one you stop. Sorry. Module name here, it is you store into the core module name, right? And you have the core here is the name of the class defined in the core module. Okay, make sense? Hello? Okay.
So you're calling
Yeah.
upon.
Makes sense.
Okay. And everything, the other thing is the same. That's all. The only difference here, that's when you separate it, when you store it separate. The first step you have to use the module name, and after that you work with the class name here. Okay. Now we learn about the object oriented. You have the encapsulation, right? You encapsulate every attribute and method in the object here. The second thing is the abstraction. That means you can hide the data or you can hide the method to the public here. Right? That in the case in object data attribute should be private. You do not want everyone to see what is the attribute of the data here. Right? And you only want to expose it to the other one when you want. So to make sure of this, you have to use you have to place a 2 underscore in front of the attribute name here. Now think about this one here. You can think about the example of the clock, right? When you see the clock, you need about hour, about the minutes, and about the second here. So if you want to store them and add a private, you use the 2 underscore before in front of the attribute name here. That is a private. Okay, so back to our example here. Back to our example. For all the method here, you have no parameter, right? You have no parameter. The cell here is not parameter. Cell here that tell you that you are working with the instance. You are working here, right? But in the method of the any class, of course, you can define it with the one no parameter or one parameter or 2 parameter. It totally is up to you. It totally is up to you. So think about this one here. Think about this example here. Okay, here. Class method can have the multiple parameter in addition to the self. Right? So for the init parameter, need to create an instance of the class. So think about I want to create a class with a bank account object here. We create with the balance, right? So we see at the beginning, I need to get the initialize method here to receive the value to assign to the balance attribute. I think about whenever you generate account, you need to tell how much balance he has, right? At the beginning, he can have 1,000 or 2,000 or whatever. You can do that, and you can in that case you need one more parameter, and this is a balance. This is a balance attribute here. And remember that sometimes I mentioned the attribute, and sometimes I mentioned the parameter. They are the same, right? They're the same here. Okay, so now think about this one here. If you think about this program, if you look on this program here, if you look on this program, the first step here, I create the class with the name of bank account, right? Now, if you look on this one here, if you look on the init method here, if you look on the init method here, it not only has the self but also have another attribute or parameter here, right? The balance here, all right? And that's a big thing. I assign the attribute balance with the value you got it from the way you define here. All right? So now on this class also I define other method here. Deposit. That means how much money you want to deposit, right? And of course, deposit that means you have the whenever you deposit how much money you add it to the balance you have, right? Also you have withdraw, and okay, in the withdraw you have to check if you withdraw more than the balance or not, right? So in the case if the balance greater than the amount you want to withdraw, of course you can withdraw it, but not right. It's not here. You have to bring out. You have insufficient. You have an insufficient balance. I think the balance here, not fun here. And the last step here, after you do everything with the deposit, and after you do everything with the withdraw, you have to bring it down. What is your balance right now? Okay, that makes sense. So see, for this one is also the thing in that slide that it want to tell you that whenever you define the class and when you define the init method, you can create another parameter. So it's not only itself. So see, this one I store into the bank account module. I store in the bank account module, and it's my main program here. I store it in transaction, right? And again, remember that when it's in my program, the first step I have to import the module where I define the bank account here, right? So where I define the bank account here. Okay, so in the main program here, I got the balance. I got the balance here, and this one here. Whenever I got the balance, I can passing it into the instance where I create here. Right? That is the module name. That it is a class name. Let's see for this one. For this class here, you have one parameter. It's a balance. It's a start balance here. Right? The last time you do not have anything here. The last time when you work with the coin, you have no parameter here. Right? But this one, you can passing it. You can passing the start balance into the parameter of the object. Sorry, of the class here. And also, you have how much what you pay. Right? What you pay, and of course, you can call this one here. You can call this one. Saving is the name of the class of the instance. Right? The name of the instance here. And deposit it is a method of instance, right? And the pay is what you passing it here. So exactly this one exactly is the same when we define the function, right? When you define the function, you passing the value into the parameter of the function. Make sense? So actually it is quite the same here, right? And after that, after you deposit, you have to print it out. What is your balance now? And also the cash here, that means how much you want to withdraw, right? See how much you want to withdraw here. So after withdraw, you have to print it out. You have to update here. You have to deduct it from how much money you withdraw. And the last thing here, you have to update what is your current balance right now. Okay, after you do with the deposit and after you do with the withdrawal here. Make sense? Okay. So you can see it again. You can see it again when we run it here. You can see it again when we run it program here. So basically, you see the first I create the bank account into the module name bank account here. Right? I stored in the bank account in the module. Where my bank account? Yes, this one. That is the module here. Right? That is step I define the code for the how to create the bank account classic bank account. You see the only difference here. It has one more parameter. It is a starting balance. It's starting balance, and you assign the cell balance to the balance here is attribute, and you assign to the value classic. The cell for the withdraw, you have the amount how much you want to withdraw, and for the deposit, you have the amount how much money you want to deposit here. Now you go to the transaction, right? So when you go to the transaction, where my transaction? Yeah, my transaction here, right? The first step, you have to import the module name. It is named bank account, right? So in the main program, I got the balance, starting balance. I create the instance here, right? That's the module name. That is a class name, and you passing the value to the parameter starting balance, right? And you do the same with the other method here. So when I run it, right? So we think, well, I have starting balance 1,000 here. How much you paid for this work? I have 4,000. How much you would like to withdraw? You have 2,500. Now the account balance here is right. So basically, it is quite the same with the function here. The only thing that you have to understand how to work with the class, how to generate instance class, and how to call the method. Right? And everything other works the same. It passing value into the method. Make sense? Okay. Now we have the string. I don't know if it's a called string method or STR method, but I call it string method here. Sometimes you need to print it out the object state. And object state, the thing if you think about in the case of the coin, it only head or tail, right? The object state of the coin instance is a head or tail, and object of the bank account it is how much, what is your balance? It is object state here. It is the value of the object attribute at a given moment. Right? So think about a coin. At the beginning, you have the value of the object attribute of the coin. At the beginning, it's a head, but after you toss it, it can be head or tail. The same with this one here. The same with the object of the same thing here. Right? At the beginning, you have starting balance, but after you do with the deposit and after you do with the withdrawal, you have to update it. It's the current balance you have here. Right? So object state is the value of the object attribute at a given moment, at the specific moment here. And string method here displays the object state. And remember here, it's very important here. It will automatically call when the object is passed as an argument to the print function. So basically, if you use the print function and you in the print function you have parameter, it is an object. It is object name. It will print out what is the state of the object here. And automatically call when the object is passed with the string function. Now think about this one here. Now think about this one. I modify this program here. I modify this program, right? In the program, I define one more method here. I define one more method. Here I define it in one method. It defines string method here, and this one here. It returns the balance. That is the current balance, right? Okay, current balance. What is the balance here? Now for this one here, after I using the function, after this step here, see after this step when I using the function, print here, and the parameter is the object name. It's the object name. It will take it out. It will take it out the attribute value of the sibling. Of course, in the sibling attribute, it's a balance. Right? Make sense? Okay. So for this one here, I go with the transaction number 2. For this one, you can see my program. Transaction number 2 here. Why I have so many? This one. Here, I see. I just call the print function, and the parameter of the function here it is the object name. Right? So we print now what is the balance I have here. Okay. So for this one, I do not have to use a for this one here. Right? Let's see. Why only have one function? Okay. Why was that? Okay. Look very well. Okay, that's the program here. I see the first step here. I bring the sibling here, bring it out, right? At the beginning, the balance is the 4,000 here, right? And after I withdraw the 2,500, the balance now is a 1,500, right? So basically, that for this one, you see in the bank account here, right? I have to define one more. I have to define one more method. It is a string method here, right? So the purpose of the string method is only return the value of the attribute of the class only. Now you work with instant. You know that instant is where you generate it from class. You define the class, but you can generate multiple instant if you want. Instant attribute, it belongs to a specific instant of the class only. So we think about when you use a class, you generate multiple instance. But whenever we work with specific instance, each of the method is only work with the instance you are working with here. So instance attribute belong to specific instance of the class. It is created when the method uses self parameter to create an attribute, the cell that tell you are working with the instance here. And if many instances of the class are created, each would have its own set of attributes. Right? Think about this one here. I come back to the coin module here, right? That's why I import the coin module here. Now for this one, for this time, I generate 3 instances, not only one. Not only one instance here. I see I have a coin number 1, generate for 1 instance, coin number 2, and coin number 3 here. Right? Now see, if I want to see attribute of each of the instance here, I have to work with the instance name and the method here, right? So we see for this one here. So we see in this example here, this method go with instant coin 1, and this method go with the instant coin number 2, and this method go with the instant number 3. They are separate, and they belong to each specific instant here. So think about this one here. It will work exactly the same, right? So we see whenever you generate instant, the first step here, they are on head, their own head, and of course after you toss it, right? You toss coin number 1, coin number 2, and coin number 3, so they can be head or tail, whatever it is. And now stop. The last time here, you want to bring it out, get the side of the instant number 1, get side up of the instant number 2, and get side up of the instant number 3 here. Right? So again, you define the class, right? And from the class, you generate instant. You can generate 1 instant or multiple instances. And for each of instant, you can use specific method for each of the instant here. Make sense? Okay. Okay. Also, we have the definition of accessor and mutator here. Typically, all of the class data attributes are private and provide the method to access and change them. Accessor method, it return value from the class attribute without changing it. But in the mutator method, it stores or change the value of the data attribute. So basically, when you work with the accessor method here, it is a safe way for code outside the class to retrieve the value from attribute. That means you want to access and take it out value without any modification. But in the case of the mutator method, you can take it out, you can modify it. That's in your own here. So now you have, that is the example of the accessor and mutator for this one here. Now I define the class here. I define the class and it's the name of the rectangle. In that one, when you have the rectangle, you have the length and width here. You have 2 parameters. Sorry, you have 2 attributes, right? You have to add 2 attributes to go with the rectangle, right? So you have the length and width here, and assign length. You got it to the attribute of the rectangle length here, and the width you assign it to the value. So to the value of attribute of the width here. Now that is the accessor here. Accessor, that means you get the length, you just return the length here. You take it out and print in what you have here. The same with this one here. This one width here. You get the width, you just return the width here without any modification. And this one here, you have the area. Area is that you return it is the length and width here. That is the case. Now this is the mutator here. You see, when you take it out, the length, and when you take out the width, you multiply with the factor. The factor here is where you define. It can be 2 or 3 or 4. That is a mutator because you take it out and you modify it. But this one, accessor, you take it out, that's all, and you keep it the same value here. Make sense? Okay. So basically, you can see that my slide is not the same with it's not always the same with the book you read here, because I believe that the book here somehow I find too complicated and not really in good logic. That's why I modify it a lot in my slide. So
Fair enough.
yeah, I hope you find that, because you see that when you follow my slide and you see it very helpful for you to work with the assignment here. right? Because very straightforward, and you can apply everything you learn from the slide and in the class into your assignment. I see that this Cengage book is not good for me, from my point of view. It's somehow it's not really,
Cengage.
not really logic.
You mean that's the sentiment for like every class though? Cengage is
Hit and miss a lot of the time.
Yeah, I don't know why they move a lot into the Cengage, but personally, I do not like it.
I get that like Cengage is like, oh yeah, we make this universal for everyone. It's cheap, it's available everywhere.
That's right. Yeah,
That's actually probably a reason why it's bad. It's
Yeah.
cheap.
yeah, right.
I actually have a complaint about that too. I can't complete one of my homework assignments, even though I follow all the directions to clear out my cache and like cookies and stuff. And it still won't let me like access the page. It says like it's some weird code, something on the back end. It says it can't access the server, and I cannot figure for the life of me what it is. Like I've troubleshooted it a lot, so I might switch into the computer to fix it, like to do it. But like just a heads up, I'm missing some assignments because I cannot access Cengage itself.
I understand. Sometimes it happens to me.
Yeah.
Also.
No, that's the downside of Cengage. If they're down, you're screwed.
Well, the thing is they said that they're not down on their end, and like I went and like looked at like some of like the HTML coding stuff in the back end. It says it cannot access the server, and I pointed that out to them. They're like, no, it's definitely the cache and all this other stuff. And I try to wipe it all out, and I just can't figure it out. So I'm like a little frustrated, to be honest. But
the thing is that I do not set the due date for the Cengage assignment. So you can make it up with whatever you want. It's okay for me.
okay.
Provided that you learn it and then you learn something from that. It's okay for me.
you learn how bad Cengage
Yeah,
is.
I do not very much for this one. I try to do that for you to understand how it works, and you learn something from that.
Bear in mind, it's really easy to cheat with Cengage.
Yeah, I know.
the
You
programming
can,
assignment.
you can search it up on the internet and you have everything.
Yeah, versus programming assignments, you're actually looking at them.
Yeah. That's problem. That's problem. And I have no way to modify this again.
Oh, that's even worse. You can't even, you like look at all these problems and are like, wow, a lot of these are trash and horrible for students to practice with.
I mean, they're not, like, if you wanna take a different approach, they're not bad if you wanna try and figure out how to break the grading system so that you get 100% by cheating. So like, it's not a bad way to think about it that way. It's just important that that's
Yeah,
how you have to do it.
everything has a two sides, right? Yeah, of course. I cannot, I do not 100 completely deny it, but yeah, it depends on you. You can text.
I mean,
Yeah.
one example of Cengage being bad is they kept referencing how gigabyte is only 1,000 bits. And I was like, what the heck does that mean?
So make it short, okay.
You think like a gigabyte, 1,000 megabytes?
Yeah, but they said
Two
the
rated power
gigabyte is
actually 1024.
but they're just saying like it's like 1,000 bits. What are you talking about? But you know, you just give up and just move on. You don't question it. Especially their test. I remember one of the questions, I forget what it was, informatics. The question was the car fill in the blank. I was like, what do you want from me?
The car, of course. That's right, the car does not exist.
It was so stupid, but whatever.
Okay, so that is the example when you understand about the accessor and mutator. Remember, accessor is just check it out the attribute without any modification. But for the mutator, you take it out and you can modify it. So for this one, this program, it's a factor here. So he can enter the number 2 or 3 or whatever, and he can modify it. Right? So for this program, you see at the beginning, I have the rectangle with the length 20 and the width is 10 here. I generate the distance from that one. I print it out. The length, width, area, I think exactly the same. Exactly from here. Exactly from the original one here. Right? and x-axis here. Now I want to enlarge it into 2 times. Change it here. The length is now 40, and the width now is 20, and the area now 800. Okay, so that's the definition about the x-axis and the multi-theorem. So I think that's all for today. It's too much information about the class, and we'll go over lecture on Thursday. Okay, and I hopefully we finish everything on the class. And next week we work with home with assignment. You work assignment again. I just want to remind you again that even that we do not have the lecture, but I'm still available on the class, and you can join Zoom meeting whenever you want, right? And you can raise any question to me, and if you need any help from me with the assignment or homework or whatever, you are free to join me on the campus or on the Zoom meeting. Make sense? Okay. You have any question?
No, don't think so. Thank you.
Okay. Okay, so with no questions, I see you guys on Thursday. Bye bye. I talk too much and I'm tired now.
It's also the mornings.